In this video, we are going to study unilateral Laplace transform, or it is also called as one-sided Laplace transform. So let us see first the equation of this unilateral Laplace transform. So we know that Laplace transform is denoted as x of s equal to integration. Now whenever it is one-sided, remember that the limits of this Laplace transform will start at 0 and end at infinity. Therefore, this unilateral Laplace transform is mostly used in case of causal signals. The remaining equation will be as it is, x of t into e raised to minus st dt. So as we said, this Laplace transform is used for causal signals. Now, if we look at unilateral Laplace transform and the other version, which is bilateral, where the limits are from minus infinity to plus infinity, all the properties of unilateral and bilateral Laplace transforms are almost identical, but only the change is in the differentiation property. So for unilateral Laplace transform, the differentiation property is defined as, so if we have d by dt of x of t, then its Laplace transform is denoted as s into x of s minus small x of 0 minus. So where this x of 0 minus, this is called as initial condition. Similarly, in generalized terms, if we have this differentiation property of, let's say, nth order, then the equation is represented as, now see here carefully, here the order of derivative is n, so s raised to n into x of s, so minus s raised to, so go on decreasing the power of s, n minus 1, x of 0 minus, which is the initial condition, minus s raised to n minus 2. Now take derivative of this function x represented by x dash of 0 minus minus so on up to the power of s becomes 0, so s raised to 0 will be 1, and x dash of, now here the order of, so we'll write one more term so that it will be more clear to everyone, so just wait for a minute. So next term will be s raised to n minus 3 x double dash of 0 minus minus, so here go on decreasing the power of s and go on increasing the order of derivative of small x. So in this way, if we go on finding out the next terms, the last term will be x with n minus 1th derivative of 0 minus. So in this way, this is the generalized equation for differentiation property in case of unilateral Laplace transform, where x of 0 minus represents the initial condition.